Most of the AI used today, from chatbot to advanced search engine, runs on RAG that lets AI tap into fresh external knowledge to answer your question. But most of the RAG pipeline exists today is fundamentally broken, as its two main jobs, finding information and writing an answer, are two separate entities that never talk to each other during training. They work like two employees who refuse to speak to each other, resulting in an answer that is slow, disjointed, and often hallucinated. But a new framework called CLaRa is fixing this by fusing retrieval and reasoning into single continuous process. And in this video, we are going to break down how its unique training process and end-to-end design are redefining the limits of AI reasoning. Let's first understand the biggest limitation of old school RAG. Imagine you have a retriever which acts as a librarian and a generator which is a researcher. The researcher asks for a book on a topic, and the librarian, using vector search, grab what it thinks are the most relevant books and hand them over to the researcher. And again, the researcher has to slog through these entire documents, piece the information together, and write a final report. This system has two massive flaws. First, the two systems never learn from each other. If the generator gets a piles of book and realizes they are useless for writing a good answer, it has no way to tell the librarian, hey, stop bringing me these books. Because the retriever that trains separately judges only on whether it's find documents that seem similar, not on how useful they actually are to generating the final answer. In machine learning, this is called broken gradient. The feedback loop is completely missing. Furthermore, there is a massive efficiency mismatch. Retriever work in a mathematical embedding space, but generator still have to process raw text. It means it has to reprocess every single word every single time. This leads to redundant text processing, expensive, and leads to context overflow, where the AI simply forgets the middle of the document because it's too long. This is the very reason models have context window limits. It will fix by merging the librarian and the researcher into one single continuous learning brain, a system where the act of writing an answer actively teaches and retriever how to find the better information next time. That's the bold promise of CLaRa, that is continuous latent reasoning. In CLaRa, the retriever don't just fetch books, it reads and understands them fast. It then creates an ultra condensed summary for each of the book. But this is not a summary of words. It's dense numerical representation of the book's core idea, which are called as memory tokens. Think of memory token as the pure essence of a document. 1,000-page documents might be squeezed down into just a handful of these memory tokens. This is the first big idea, extreme meaning preserving compressor. Now, when generator needs information, it doesn't ask for books. It asks for the most relevant memory tokens. Then the whole process becomes dramatically faster. We are talking about the compression ratios of 16 times 32 times or even up to 128 times. Both the retriever and the generator are now operating in the same language, the language of these continuous latent vectors or memory tokens. And because they are connected in this space, a feedback loop can finally be established. If the generator discovers a certain memory token was not helpful for building a quality answer, the feedback can flow all the way back to the retriever. This is the jump from disconnected search, then read process to a unified continuous reasoning process. CLaRa creates a single system that learns from end to end how to find and reason about information in the most effective way possible. CLaRa actually pulled this up with a two-stage training process. First stage is Salient compressor pre-training. The entire CLaRa framework is built on the quality of its memory tokens. If the compression process loses its key information, the whole system fails. The goal is to train a specialized model, the document compressor, that turns long document into short, meaningful memory tokens that capture only the most important content. But how do you teach a model what's important? The CLaRa developed a data synthesis framework using a teacher large language model to generate a synthetic curriculum from a huge corpus. For each document, the teacher LLM generates several types of training data, like simple question-answer pairs. These are basic facts pulled directly from the text that ensures the compressor hold on to specific hard facts. Next is complex multi-hop questions. These questions require the model to link multiple facts together. This teaches the compressor to preserve the relationship between facts. And finally, paraphrases, that the teacher model also rewrites parts of the document, rephrasing and condensing them. This forces the compressor to learn the semantic meaning of the text, not just for its word-for-word structure. A iterative verification loop by the same LLM even double checks that the generated questions and answers maintains factual consistency and information coverage. Now, the system uses single share-based large language model, which is different from the teacher LLM, with two specific LoRa adapters. One is compressor LoRa, another is generator LoRa, that get trained with this dataset with two main objectives. First is cross entropy loss. The generator part of the model has to learn to answer the questions using only the compressed memory token as its only source of information instead of the raw text. This is the powerful constraint that forces the memory token to become incredibly information dense. The second objective is mean squared error loss. It basically ensures the compressed representation stays in the same general semantic neighborhood as the original document. The result of stage 1 is highly effective document compressor large language models that can take document of thousands of tokens and distill its essence into just 4 or 8 continuous vectors that can generate answer from compressed memory tokens as the source of information. This pre-trained compressor is for general purpose, and it can be furthermore instruction fine-tuned based on the task type. CLaRa unifies retrieval and generation by training both within a single pre-trained large language models through a differentiable retrieval module. To achieve end-to-end training requires a retrieval space that is stable and computationally manageable. To solve this, we use the compressor trained in SCP to produce high-quality impact representation that remains stable even when the rest of the model updates. With a powerful compressor gets ready, we head to stage 2. That is where CLaRa starts to repair that broken connection between retrieval and generation. The goal is to train the query reasoner, that is a LoRa adapter initialized from the compressor, and the answer generator, together using the memory tokens generated from the stage 1. Through next token prediction training, the query reasoner learns not only to encode query intent, but also to anticipate the relevant document content, enhancing retrieval and answer generation process. Now, the retriever's job is to look at the user's query, scan a library of compressed memory token, and pick the top K most relevant, for example, top 5. This top K document compress embedding retrieved by retriever are concatenated with query embedding and fed to the generator, which produce the final answer. During training, both the query reasoner and the generator are updated via the unified language modeling loss using a candidate document question answer triplets. This allows the retriever to learn through weak supervision from the generation objective without explicit re-ranking labels. Here, CLaRa used a differentiable top-K selection, that is a top-K selector via straight through estimator that acts like a special lens that behaves differently during the forward and backward parts of training. During the forward pass, when making a prediction or generating answer, the system does a normal hard top-K selection using cosine similarity. And during the backward pass, while learning from mistakes, instead of hitting from dead end, the straight through estimator swaps the hard selection with a soft differentiable approximation. Essentially, during the learning phase, every document is considered to have contributed to the answer to some degree. The retriever learns to give higher score to documents that actually help the generator produce a better answer. And it all happens under one single unified goal, predicting the next token correctly to generate the best final answer. There are no separate messy loss functions. The entire system is optimized as one. This joint training is done on instruction-based dataset, aligning both the retriever and generator in a shared space that optimizes for reasoning. So CLaRa is not just a slightly better RAG, it's a sign of fundamental shift. It points towards a future of compressed native AI. CLaRa shows that they can be solved as one unified task inside a shared continuous latent space. This approach fixes the biggest headache with today's RAG system by enabling a true end-to-end learning. The retriever finally understands what information is actually useful for creating a good answer. Imagine an AI system that can reason over entire company's knowledge base, a vast scientific library, or real-time global internal thought space for finding and thinking about information. Let me know what you can think in the comments. What application are you most excited to see? And if you enjoy the breakdown, make sure to subscribe the channel and hit the bell icon for more explainer of the future of AI. Thanks for watching.